Alright, so here's another kind of random idea for you, but we've talked about standard deviation and how spread out your sampling distribution is. We can change that, and we can change that by changing the sample size. Okay, and so here, we've talked about before in class, the bigger the sample, the smaller the standard deviation of your sampling distribution, whether that's your standard deviation or whether this is your standard deviation. Either way, bigger sample, smaller standard deviation of your sampling distribution. Okay, and that's good because that means that you're less spread out and you're going to be more exact. Okay, so a lot of times you are going to want to reduce the standard deviation because it's going to make everything more centered around the actual mean. And in order to do that, we are going to have to be more exact, to be precise, we are going to have to make our sample larger. So the question is, how much larger? And let's look at that. So here's an example. It says we want to reduce the sampling distribution standard deviation by a factor of 5. Okay, so let's check this out here. Factor of 5. If I want to reduce something by a factor of 5, well, I would probably want to divide by 5. But let's just take a moment and find the standard deviation over here. Okay, the standard deviation, we have the population standard deviation divided by n, which remember, here, we'll kind of label these just for funsies. This right here is the population standard deviation. At this point, you should know that. And this right here is your sample size. You should definitely also know that at this point. Okay, plug in your numbers and you're going to get out here 5 is your sampling distribution mean. Oh, that's the wrong way. Okay, moving on here, we want to decrease this by a factor of 5. That means we would want to probably divide it by 5. Okay, so whatever it is, we're going to want to have our sampling distribution divided by 5 when we're done, and so we're probably going to want this to end up as a 1. How do we do that? How are we going to make this work? So let's just think about what it would be to divide this by 5. So we're going to keep the same population standard deviation. We can't change that. But we can change what goes on the denominator here. We can change the sample size, and that's what they're asking us to do. We're going to want to divide this by 5. Okay? But right now they're asking, what does that do to our n? So just bear with me for a second. Watch what I do here. Is it true that you could rewrite this, if you really wanted to, you could rewrite it like so? Right, where you have 5 to the square root of 5 with 5 squared, that's the same thing as 5. So you could rewrite it that way. And if you really wanted to, you could rewrite it again such that you have this. Do you agree that I could write that? That's 5 squared times 81. We're just rearranging some things. And if you look here, what did I end up doing to my original sample size? This was my original sample size, and now I'm multiplying it by whatever I wanted to reduce it by squared. So right here, if we want to reduce our standard deviation by a factor of f, we are actually, this is just what we're going to notice, we are going to multiply n by f squared. And if we do all of this out, this will actually end up giving you 1. If you type in 45 divided by the square root of 5 squared times 81, it'll actually give you 1. Okay, so we're working our way backwards here. Let's look at another one and kind of see how this works. So on this one, it says we want to reduce our original by a half. So that means if we're reducing by a half, we're going to divide by 2. So whatever our answer is here, Okay, when you do this part out, we get 6 as the answer. And we are going to want to divide that by 2, because we want to reduce it by a half. So we know we want our answer to be 3, but the question is, what happens to n? And so let's kind of work our way backwards here. Our population, our standard deviation for our population is 60. And how did I get from here to here? I'm going to need to divide by 2. So I'm going to divide my original by 2 and still multiply here. And again, if I want to rewrite this, I could hypothetically rewrite it as 60 over this, the square root of 2 squared. It's the same thing as 2 times the square root of 100. And if I really wanted to, I could rewrite it as the square root of 2 squared times 100. And in this case, again, you would still see that here, if I want to reduce my standard deviation by a factor of 2, I'm going to have to multiply my n. Let's see where our n is. Here's the n. We multiplied it by what the factor we were trying to reduce, squared. Here is n, right here. And we're going to have to multiply that by whatever we're trying to reduce, squared. Let's try one more of these. It says we want to reduce the sampling distribution, standard deviation, that's this, by 1/4 of the original. So here's the original, OG original, and we want to make it, the new one, 1/4 of that. So what is going to happen here is we are going to want to divide this by 4, because we want it to be 1/4 of the original. And again, we can already spy on the answer. I already know I'm going to want to end up with this as my answer, because 0.1 divided by 4 is going to give me that. But let's come over here and check out what we would have to change in order for this to work out. So let's plug in the stuff that we know. The probability, or the proportion of the population is 0.4 times 0.6 over n. And this time we know that we want to divide by 4. So we are going to divide this thing by 4. Well, in order to divide this by 4, we need to get that inside of the radical. So if I was to move 4 or divide by 4, in order to get that in the radical, or radicand, whatever, okay, we are going to have to, still want it on the bottom, we're going to have to keep it the same, preserve its 4, and make it 4 squared. Because when it goes underneath the square root, those kind of cancel out. Okay? Oops, I don't know why I kept n here. This is 24. And this is 24. So again, we see that the sample size ends up getting multiplied by the factor we're trying to reduce squared. Okay, so when we come down here, it says if we try to decrease the standard deviation of the sampling distribution, if we're trying to decrease that by a certain factor, okay, we are going to have to increase n by f squared. And that is kind of what's happening. Definitely a little bit different to think about, but it's not the worst thing ever. It's just the idea that when we put something underneath a radical, multiply underneath the radical, we have to square it to preserve itself. Alright, and that's all for now.